In this problem, we have this scenario, and we can use our laws of conservation of energy to solve it. And we know that the ball has a total amount of energy, that is the mechanical energy it has. So it has some E. That is conserved, it is constant. Energy cannot be created or destroyed. So we have the same amount of energy, but we have it in different forms. We can have it as kinetic energy, or we can have it as gravitational potential energy. And whenever kinetic energy is higher, it'll have a higher velocity, because remember that kinetic energy is proportional to the velocity squared. So what we want to find to rank its velocity is where does it have the largest amount of kinetic energy. So we know that to gain kinetic energy, we need to lose gravitational potential energy. And gravitational potential energy is proportional to height. That means that kinetic energy will increase as the ball goes down. So here we have more, here we have less kinetic energy. Now the lowest point is C. So we know that the highest velocity will be at C. So we have V at C is greater than all the other velocities. Now where do those other velocities fit in? We have B and C that are at the same height, but they are not as high as A. So we know that B and C are going to have the same velocity, but they are not as slow as A. So that means that VB equals VC. And finally, at point A, it has a lot of gravitational potential energy, but it has less kinetic energy. So the lowest velocity will be at A. And that is our final answer.